You've heard Billie Eilish's song about it. You may have seen some headlines about it. But what is the deal with the asteroid that could hit Earth in 2025? Could it really trigger earthquakes all around the world? Let's start at the beginning. This asteroid is called 2025 QN, and it's about 1 kilometer wide. So far, so big. That's about 621 miles for our American friends. But there are lots of big asteroids out there. This one has been known to astronomers since 1999. They just haven't been able to observe it very well because it's so dark. Asteroids like this tend to be made of carbonaceous chondrite material, which means they absorb most of the sunlight that hits them. So why have we suddenly started worrying about this particular big black asteroid? Well, back in March 2023, astronomers calculated that this asteroid might pass close to Earth in 2025, like uncomfortably close. We're talking about within 3 million miles. To put that into context, the Moon is about 238,000 miles away, and whilst an asteroid that size hitting the Earth would be pretty devastating, 3 million miles isn't close enough to cause global earthquakes. But it was close enough that astronomers wanted to keep watching it to be sure. Now, if you're wondering how astronomers can tell how far away an asteroid is, it's by measuring its brightness. If it looks brighter, it's closer. And then they use a technique called radar, ranging to measure how fast the asteroid is moving towards us. The faster it moves, the closer it's going to get. The way radar works is that you send out a radio signal, and then you listen for it to bounce back off the asteroid. Then you can calculate how far away it is based on how long it took for the signal to come back. But this only works if the asteroid is big enough to reflect enough of the signal back to you. Astronomers call this the asteroid's radar cross-section, and for an asteroid this small, the radar cross-section is less than 10 meters squared. To put that into context, the average person is about roughly 5 feet tall, so their radar cross-section would be something like 14 meters squared. I realize that my understanding of human anatomy is extremely poor, because I calculated this using the area of a circle, and my math skills haven't improved much since high school. So take that value with a grain of salt. But the point is that this asteroid is about 100 times smaller than the average person, and so it reflects 100 times less radar than the average person. In fact, when astronomers tried to get their radar working on this thing, they basically had to use every single radar they could find around the world to even get a response. Even then, the asteroid was only visible from April to May 2023, and it was only visible because Earth's atmosphere was doing something weird. Usually, it scatters radio waves all over the place. The good news is that this asteroid doesn't seem to be heading for Earth in 2025. In fact, astronomers think that it won't pass close to Earth until sometime between 2206 and 2212. So that's exciting. But it does mean that we have to wait another 200 years to check if they were right. And here's where things get kind of spooky. Back in 1908, there was a massive explosion near Siberia that was caused by an asteroid. This was the Tunguska event. The asteroid didn't hit the ground, but it must have exploded with a force equivalent to about 12 megatons of TNT. For comparison, the biggest bomb ever detonated on Earth was about 62 megatons. The energy from the explosion flattened trees over an area of about 830 square miles. It was felt as far away as London and Washington, D.C., and yet the crater was never found. Now there have been lots of expeditions to go and look for this crater, and all they've managed to find are some boulders with a high concentration of nickel and cobalt. The nickel-cobalt is interesting because it's a feature of meteorites called urelites, and those meteorites are all linked together genetically. That is to say, they all come from the same asteroid. But nobody has ever found the actual space rock itself. So we don't know for sure that the Tunguska event was caused by an asteroid. The reason this is important is that if the asteroid that hit Tunguska was about 1 kilometer wide, then the asteroid that might hit us in 2025 should also be about 1 kilometer wide, and if it hits us, then yes, it will trigger earthquakes all around the world. Okay, so let's assume that the 2025 asteroid is 1 kilometer wide. What sort of damage would that do? Well, We already know the answer because there's a meteorite that's so similar to this hypothetical asteroid that it's often used as a model. It's called the Chelyabinsk meteor. This is the meteorite that caused the Tunguska event. On February 2013, it entered the Earth's atmosphere over Russia and exploded with a force of about 300 kilotons. The shockwave generated by the explosion shattered windows across 6 different time zones and injured 1,000 plus people. A lot of people died as a result of the injuries sustained from the shockwave. In fact, the damage caused by the meteor was about $33 million, or about 40 million pounds. But what if the asteroid wasn't so perfectly modeled after the Chelyabinsk meteor? What if it was bigger or smaller? Well, NASA's Jet Propulsion Laboratory did some simulations and they came up with some truly terrifying results. Here's a table showing the impactor mass on the y-axis against the maximum earthquake magnitude on the x-axis. Each line represents a different impact speed. The orange line represents an asteroid that's traveling at about 45 kilometers per second. And we can see that if the asteroid is about 400 meters wide, it will cause an earthquake that's a magnitude 7.7 on the Richter scale. That's pretty much the worst-case scenario. It would be the most powerful earthquake ever recorded on Earth, and it would be felt all over the world. Now, if the asteroid was slightly smaller or slightly larger, the earthquake wouldn't be as bad. If it was about 600 meters wide, then it would cause a magnitude 7.4 earthquake. Interestingly, the biggest earthquake ever recorded on Earth is currently about a magnitude 9.6. That was the 1960 Valdivia earthquake in Chile. If the asteroid was traveling significantly slower, then the earthquake would be significantly weaker. But even a magnitude 7 earthquake would be catastrophic. Now, let's change the speed to 25 kilometers per second, which is the lower end of what's expected for asteroids. If the asteroid was about 1,000 meters wide, then we'd expect it to cause an earthquake of about magnitude 6.8. At 400 meters wide, it would be a magnitude 7.2, and at 600 meters wide, it would be a magnitude 7. Okay, so now let's imagine the worst-case scenario. An asteroid that's 400 meters wide, coming in at 45 kilometers per second. What sort of damage would that do? Well, NASA predicts that the asteroid would leave a crater about 60 miles across and 1 mile deep. The dust cloud generated by the impact would block out the sun and cause global temperatures to plummet by about 18 degrees Fahrenheit or 10 degrees Celsius. According to NASA, 2 billion people would be affected by crop failure, and billions of tons of debris would fall from the sky, causing secondary impacts. And of course, the seismic activity would be felt all around the world. Let me summarize that. People would die on a scale that we haven't seen in a very long time. Okay, so the worst-case scenario is clearly not good. But what's the best-case scenario? Well, the best-case scenario is probably that the asteroid misses the Earth entirely. NASA thinks that there's about a 1% chance that it'll pass within 4-6 million miles of Earth in 2025. If that happens, then yeah, we'll definitely see it, but it won't do any damage. The second best-case scenario is that the asteroid hits the moon instead, and NASA thinks there's a 5% chance that that might happen. If it hits the moon, it would leave a new crater on the near side, and then we could watch that happen in real time. The third best-case scenario is that it hits the moon, and then it breaks up in the process. And NASA thinks that there's a 5% chance that might happen too. If it broke up, then there's a 5% chance that some of the fragments would hit Earth and cause earthquakes. But at least we'd get a meteor shower out of it. And finally, the fourth best-case scenario is that it hits Earth, and it's not a direct hit. In this scenario, the asteroid would still cause an earthquake, it would just be less catastrophic. NASA thinks that there's a 10% chance of that happening. To me, that sounds like a roll of the dice. But there's something else that I want to talk about. Last year, researchers suggested that we should try and nudge this asteroid off course using lasers. The idea is that by shining a continuous laser on one side of the asteroid, you could slowly push it further away from Earth. The problem is that we're not very good at aiming lasers, and at the moment, we can't aim them accurately enough to guarantee that we would miss. If we were going to try and do this, then we'd need to start soon. By 2027, it will be too late because the asteroid will be inside the Moon's orbit. Once it's inside the Moon's orbit, it's going to be very difficult to get an accurate enough measurement of its position to make this work. And the risk is that we could end up pushing it closer to Earth. I guess the moral of the story is that if you want to deflect an asteroid, you'd better do it sooner rather than later. As always, it's been an absolute pleasure. If you want to know more about how we calculate the orbit of asteroids, then I recommend checking out Real Engineering's video on the subject. I'll leave a link in the description. And as always, thank you so much for watching. I'll see you in the next video.